Good day guys! So in this video, I'm going to show you the solution to the sample problems which I posted regarding dual combustion cycle. So we have here our TS diagram and our PV diagram for the said cycle. Process 1 to 2 is isentropic compression. Process 2 to 3 isometric heat addition. Process 3 to 4 is isobaric heat addition. 4 to 5 is isentropic expansion. And process 5 to 1 is isometric heat rejection. So we have 5 processes. And meron tayong dalawang processes dito na for heat addition. Therefore, kung kukuhanin natin ng QA, QA is equal to QX plus QY. Isang isometric and isang isobaric heat addition. Now, let us read the problem first. So, babasahin ko lang muna yung problem. In a dual combustion cycle, the maximum temperature is 2,000 degrees Celsius. T4 is 2,000. Maximum temperature, nasa 0.4. And the maximum pressure is 70 bar. So, as you can see, yung process 3 to 4 is isobaric, meaning yung ating pressure is constant. P3 is equal to P4. So, that is our maximum pressure equivalent to 70 bar. Calculate the cycle efficiency and the mean effective pressure when the temperature and pressure at the start of compression. So, at the start of compression is 0.1. We have pressure equivalent to 1 bar and 17 degrees Celsius of temperature. The compression ratio is 18:1. So, RK is 18. Now, how are we going to solve for the cycle efficiency? Our general formula for efficiency is work net over QA. And for the mean effective pressure naman, we are going to use the formula work net over volume displacement, wherein our volume displacement is still V1 minus V2. As you can see here, V1 is our maximum volume, V2 is our minimum volume. So, V1 or V5 and V2 or V3. So, V1 minus V2. Let us start. So, paano natin isosolve si efficiency? Work net over QA. And work net is calculated by getting the difference or the sum of all the heat na nag-occur dun sa ating cycle. And sum ng lahat ng heat is QA plus QR. And QR, ang sign niyan is negative. Therefore, work net is QA minus QR. Now, in order for us to solve for QA, we need T2, T3, and T4. For QR, we need T1 and T5. Therefore, para ma-solve natin yung work net and yung QA, kailangan muna nating kuhanin lahat ng temperature dun sa lahat ng points. Let us start with T2. T2 kasi meron na tayong T1 which is 17 degrees Celsius. Okay. So, at process 1 to 2, the process is isentropic. So, if the process is isentropic, meron na tayong na-derive na formula para doon. So, process 1 to 2, S is constant. So, si T1 or si T2 is equal to T1 RK raised to K minus 1. So, kung naaalala nyo, yan yung ating derived formula for process 1 to 2. Substituting T1 in this equation, 17 plus 273, kailangan absolute, times RK, compression ratio, 18, raised to K, which is 1.4 minus 1. So, si T2 is equal to 921.5247. So, sulat ko lang. Okay, so meron na tayong T2. Now, we are going to solve for T3. Anong process 2 to 3? Process 2 to 3, at process 2 to 3, the process is isometric or constant volume process. Anong relation ng temperature and pressure during a constant volume process? They are directly proportional, or T3 over T2 is equal to P3 over P2. Okay, so in order for us to solve for T3, we need T2, P3, and P2. And meron na tayong T2 na solve natin dito. Meron tayong P3 given 70 bar. What about P2? So wala pa tayong P2, therefore kailangan natin bumalik sa process 1 to 2 and then solve for P2. Solving for P2, P2 is equal to P1 RK raised to K. So using the relation of pressure and volume, madederive natin itong formula na ito. And P1 is 1 bar, Rk is 18 raised to k, which is 1.4. P2, therefore, is equal to 57.1981 bar. Now, we can now solve for T3. So, T3 is by cross multiplication equal to T2 times P3 over P2. Substituting the values, 921.5247 Kelvin times P3, which is 70 bar, divided by P2, which is 57.1981 bar. T3 is equal to 1127.7777 Kelvin. Now, ang sunod natin isosolve ay si T5. Kasi meron na tayo ditong T4. So, punta tayo sa process 4 to 5. At process 4 to 5, ano yung process 4 to 5? At process 4 to 5, the process is 1 to 2, 2 to 3, 3 to 4, 4 to 5. Isentropic process, isentropic expansion. And ang relation ng temperature sa volume is T4 over T5 is equal to V5 over V4 raised to K minus 1. So again, kung natatandaan nyo, kapag isentropic expansion, we have expansion ratio. Ang expansion ratio kapag dual combustion is equivalent to V5 over V4. So, we can say na si T5 ay equal sa T4 divided by the expansion ratio raised to K minus 1. Kaso, wala pa tayong expansion ratio. And meron tayong relation, again, expansion ratio is equivalent sa compression ratio divided by cut-off ratio. Kaso, wala pa po tayong cut-off ratio. Saan po ba nangyayari yung cut-off? So, yung cut-off is dito nag-o-occur sa constant pressure process. And dahil dito siya nag-o-occur, yung ating formula for cut-off ratio, ito ko na lang sulat sa taas, is equal to V4 over V3. So, kapag pinag-multiply ko, V5 over V4 times V4 over V3 is V5 over V3. Or, equivalent yun sa compression ratio. Kasi V5 is V1, V3 is V2. Gets? Sana naman po ay naintindihan. Okay? So, kailangan pa natin ng RC, kailangan natin ng RK. So, kuhanin muna natin si RC. Kaso wala po tayong volume. So, saan kaya po natin pwedeng kuhanin si RC? So, at process 3 to 4, process 3 to 4 is constant pressure process. Constant pressure process, ang relation ng volume sa temperature ay direct. They are directly proportional. So, kung meron akong T4 and T3, I can also solve for RC. Kasi RC is V4 over V3 or T4 over T3. Dahil meron naman tayong T4, which is given 2,000 degrees Celsius, paplasan ko lang ng 273 para maging Kelvin. Then, meron akong T3, yung na-solve natin kanina, 1,127.777 Kelvin. I can solve now for RC. And RC is equal to 2.0155. Now, pwede natin siyang isubstitute dito para ma-solve natin si T5. T5 is T4, 2,000 plus 273 divided by RE, which is RK, 18 over RC na 2.0155 raised to K minus 1, 1.4 minus 1. So, si T5 ay equal sa 946.768 Kelvin. Now, ita-transfer ko lang yung ating mga values ng temperature sa next page. Then, we can solve for QA, QR, and worknet. Okay, so na-transfer ko na ngayon yung mga value ng temperature natin, T1 to T5. We can solve for QX. QX is yung heat added, ito, during isometric process. QY is the heat added during isobaric process. Then, QR natin is nasa process 5 to 1. Okay. So, solving for QX, QX is MCV T3 minus T2. Since wala naman tayong mass, so per unit mass na lang yung ating kukuhanin. CV for air, kapag metric, is 0.7186 kilojoules per kilogram Kelvin. Then, T3 is equal to, ayun, 1127. Di ko na lang i-substitute, i-input ko na lang sa calcu. Meron na tayong T3, meron na rin tayong T2. So, solving for QX is equivalent to 148.2134 kilojoules. Now, substitute naman dito sa QY para ma-solve natin. CP is 1.0062 kilojoules per kilogram Kelvin. T4 is 2,000 degrees Celsius minus T3 na 1,127.777. So, QY, therefore, is equal to 1152.3227 kilojoules per kilogram. Now, let's proceed sa pagkuha ng QA. So, QA is just the sum. Yung total heat added is just the sum of QX and QY. So, adding these two, yan. Ito ay kilojoules per kilogram. Adding these two, ang ating makukuhang sagot, ang unit niya is kilojoules per kilogram. Equivalent sa QA sa 1,300.5361 kilojoules per kilogram. Now, solving for QR, again, let us just substitute these values, 946.768 minus T1. Si T1 ay naka-Celsius, so paplasan natin ng 273. So, si QR is equal to 471.9535 kilojoules per kilogram. Solving for work net, isubstitute lang natin QA minus QR. 1,300.5361 minus 471.9535. So, work net in kilojoules per kilogram is equivalent, yan, 828.5826 kilojoules per kilogram. Solving for the efficiency, again, ang ating efficiency is work net divided by QA. So, kuhanin lang natin yung isa pang papel and let us solve for the efficiency. Efficiency is work net, which is 828.5826 over QA, 1,300.5361 times 100. So, efficiency in percent is equal to 63.71%. So, ito na yung ating final answer for efficiency. Next, we are going to solve for the mean effective pressure. So, kung naaalala nyo, kanina, ating formula for VD is V1 minus V2. Let us solve for V1. Substitute lang natin, RT1 over P1. So, si R, 0.287 kilojoules or kilonewton meter per kilogram Kelvin. T1 is 17 degrees Celsius. Convert natin sa Kelvin plus 273. Then, P1 is 1 bar. So, para ma-cancel natin yung mga unit, convert natin yung bar papuntang kilopascal. 1 bar is equivalent to 100 kilopascal. So, multiply lang natin siya by 100 kilopascal. Now, ang ating V1 is equal to 0.8323 cubic meters per kilogram. So, ang unit natin is cubic meter per kilogram kasi si kilopascal, kilonewton per square meter, makakancel ang kilonewton. Ang matitira ay cubic meter per kilogram. Now, solving for V2, pinakamadali is gawin natin yung formula from compression ratio. V1 over RK. Substitute 0.8323 cubic meters per kilogram divided by RK. Ang compression ratio natin na given is equal to 18. So, si V2 is equal to 0.04624. Now, let us solve for the mean effective pressure. Work net divided by the volume displacement or V1 minus V2. So, si work net is equal to, ano ang work net natin kanina? 828.5826 kilojoules or kilonewton meter per kilogram. Divided by VD, V1 minus V2, 0.8323 minus 0.04624 cubic meters per kilogram. So, canceling out yung kilogram, cancel out yung isang meter, kilonewton per square meter is kilo Pascal. The mean effective pressure in kilopascal is equal to 1054.0959 kilopascal. So that's all. Thank you.